Okay, so let's keep on rolling. You get it? That's a pun. Because it's Rolle's theorem. Let me just focus it here. There you go. Okay, so we talked about first derivative test, what it means for a function to be increasing or decreasing. Talked about Rolle's theorem and mean value theorem. Now, let's look at the second derivative test and concavity. So today we're going to talk about concavity and the second derivative test. The second, and it's not the second at first derivative test. It is the second derivative test. It's that test. So this test is a little bit different. And it still tests for relative extrema, but it also tells us other things. So, not really. There's a test for concavity and there's a test for different. Okay, so we looked at a function meaning increasing and decreasing. Let's talk about concavity. So concavity is really only two types, just like increasing and decreasing. And you know this looks like two examples, right? The one we just did. It's really not. So when you have a bunch of statements on the right side, but I'm gonna draw some tangent lines, and you're gonna have to determine what is happening with them. You can't really see them well, but just pretend to think about the tangent lines. So let's call this M1, M2, M3, M4, M5. Okay? Let's call them that. Which one's the biggest? Which one is the greatest? It's M5, right? Which one's the least? It's the one that's most negative, right? So, what is happening? Our slope is getting bigger and bigger and bigger and bigger. So our slope is increasing from negative to positive, right? So it's increasing. It starts out negative, and then it goes up and up and up and up, and then goes to positive, up and up and up. So it's going up. The slope is increasing. Well, remember I said if f of x is increasing, f prime of x is greater than 0. Well, if f prime of x is increasing, then f double prime of x is greater than 0. This is also known as concave up. And it looks like that. So if f of x is concave up, then that means f prime of x is increasing, which means that f double prime of x is greater than 0. Well, let's look at this one. Well, here, I guess the reverse is happening. Our slope is getting smaller and smaller and smaller, and we're going smaller, negative. Smaller and smaller and smaller. It's decreasing in value. Our slope is decreasing. So I'm going to divide this into two things. So let's divide them. Whoop. So f of x is concave up. F prime of x is increasing. And f double prime of x is greater than 0. Well, in this case, our slope was decreasing, right? Which means, f prime of x, which means f double prime of x is less than 0, which also means that f of x is concave down. It's very important to make this chart kind of. It's very important. So this is concave up, and this is concave down, and this is what it means for each of the derivatives. For f to be concave down. So that's what concavity means. Well, what if you change in concavity? Remember, if we change from increasing to decreasing, we got relative extrema. Well, what if you change from concave up to concave down? Well, the change in concavity gives an inflection point. A point of inflection is what happens if you change in if you have a change in concavity. Hope you got this down. It's kind of really quick jotting down. Okay, so what does a point of inflection look like? Well, if I'm changing simply from concave up to concave down, this is obviously a point of inflection. Because from this end, f double prime of x is greater than 0. And from this end, f double prime of x is less than 0. We'll kind of guess what's over here. F double prime of x equals 0. That's what the point of inflection is. If you have a point of inflection at that point, f double prime of x equals 0. But if f double prime of x equals 0, then that doesn't mean you have a point of inflection. You have to test for it. But it is not the second derivative test. It is a test for concavity. And that's saying if you have an inflection point or you don't. The second derivative test is a test for relative extrema. But jot that down now. So let's do a cool example. Let's do it. So let's do example. Example time. Let's say f of x equals x to the third minus x squared plus 2x plus 4. And I'm just going to do that. Okay, so, right? So, okay. What do we have to do? Well, I want to find all possible places where you're concave up and concave down. And when you have points of inflection, well, we need the second derivative to tell us that. So the first derivative is 3x squared minus 2x plus 2. The second derivative will be 6x minus 2. That's not a cool second derivative, but it's easy. So let's do that little second derivative for the test for concavity. So I have I'm looking for the sine of f double prime of x. And when is it equal 0? When is that equal 0? Well, let's solve for it. Well, if we add 2 and divide it by 6, it's when x equals 1 over 3. So it's 1/3. 1/3 of 6 is 2, minus 2 is 0. So we're going to test kind of values and plug it into the second derivative, see what the signs are, and if they change, then we have a point of inflection. Now another thing is, these possible points of inflection can also occur when the second derivative is undefined. But this is never undefined. So let's plug in a point less than 1/3, like 0, into this. Well, if you plug in 0 into the second derivative, you get a negative, negative. You get a negative. What if you plug in 1? Well, you get a positive number. Something bigger than 1/3. You could plug in any number. So, what does this tell you? What does this tell you about f of x? What does it tell you about f of x? Well, it tells you that f of x is concave up, and I'll just abbreviate concave down on this interval. And it tells you that f of x is concave up on this interval because it's positive on that interval. And it tells you that there's a point of inflection at x equals 1/3. So we can kind of envision this function. That 1/3 is around here, right? So we're kind of having a concave down, so we're coming from here. We're going from, there's a... It kind of doesn't look right, right? There you go. We kind of had a concave. This is down. Sorry. Kind of concave down and then start to go concave up. But this point of inflection happened at x equals 1/3. So we can kind of envision like that. Well, we have concave up. And then inflection point, concave up. Concave down. Inflection point, concave up. We could visualize that. But we don't know how high up these are. We can kind of think about the graph. And that's really it. That's the kind of test on concavity. That's what it does. Now the second derivative test, I'm going to show you what that is. Second derivative test is an oofy. So, okay. Think about the two situations we had. Our minimum and our maximum. Now, when do relative extrema occur? At critical points. They occur at critical points. When do we need critical points? When f prime of x equals 0. So we have to know when f prime of x equals 0. We have to know these critical points. Now, to figure out what type of relative extrema we need, look at what's the sign of f double prime? Here. It's positive, right? So it's greater than 0. So if we have these two conditions, we have a relative min, right? We have a min. Well, in this case, we have a critical point. So f prime of x equals 0. What's the sign of f double prime of x? Well, it's less than 0, because it's concave down. Well, then we have a max, a relative max. And that's what the second derivative does. Is you test all your critical points, you plug it into the second derivative, and if it's positive or negative, you know which one it is. Now, if you get 0, you get an issue. That means that maybe it's a possible inflection point, and not a relative min or max. So that's what that does. I'm not going to do examples because it's kind of easy to do. I told you already how to do it. You got to find your critical points, and you got to set them, find the sign of the second derivative at that point. And then you'll have the function that you want. Okay, so we have a lot of time left. That's okay. Let's review kind of all the tests. Let's do a little bit of a combo thing. So remember, so if I say, okay, f double prime is greater than 0, right? So that means what? F prime of x is increasing, and f of x is concave up. What if we had f prime of x is decreasing? Well, then we know f double prime of x is less than 0, and f of x is concave down. And if we know that f of x is concave up, then f prime of x is increasing, and f double prime of x is greater than 0. So we gotta know what every level of your derivative represents when these things happen. That's really it. It's not that much. I'll give you an example. So take this function x squared plus 2 over the root of x. And your job is to find all relative extrema. You can use the first derivative test, the second derivative test. For this one, I'll probably recommend the first, because I don't want to take a second derivative of that. That's a hard one. And find intervals where f of x is increasing, decreasing, concave up, and concave down. This is using all of your knowledge right now from the past lessons to find all these things. You have to know how to do this before we go on to the next section, which is curve sketching. So do that problem. And that's after that.